Thank you. Um, I'd like to talk you through the way we think and work with architecture at our office. My name is Kasper. I'm a partner in 3XN Architects, and my business in the company is to run our innovation focus. It's called GXN. We're a group of 10 people. First, I'll just share a few photos of the office. As you can see, we are a group of 80 people doing a lot of projects from Copenhagen, where we're situated. We tend to work a lot together in project teams, obviously, and work a lot with models. So this is the office you see, like example on an arena we recently won. But the thing is, I'm not going to talk too much about architecture as kind of a general approach. I'm more going to talk about how we work with parallel investigations in the work of the office. So I'd like to start out talking a bit about mushrooms, for example. So mushrooms, to many people, is something that you actually really want to keep out of your building, of your structures, due to moisture damages, etc. To me and to my team, we see mushrooms as a potential. Actually, looking at how mushrooms' roots, the mycelium, is able to bind things together in a way so you can start to grow material and talk about materials that requires no energy in the making. And also, like a natural organism, a mushroom can take upon any shape you desire. In that way, we can start to think about designing materials. I'm going to talk a lot about that today. Normally, design is something you refer to in the scale of a chair, on the scale of a building. And in my world, it's very much about how you can design materials, how materials is something that is an answer to your questions. This, for example, is resulting in structural and acoustical panels, but we're also developing other projects where it's in much more free-form shaped, taking advantage of this kind of a live organism. So GXN, we're the innovation unit of 3XN Architects. We are a group of 10 people. We are a mix of engineers, designers, architects, also a psychologist. So we sit and work from the office and work inside and outside of our projects. Parallel to that, we also do longer term research projects where we are taking focus on materials, new digital tooling technologies, manufacturing methods, and try to build up a knowledge that we then can introduce in the projects when the kind of insight is mature enough to be applied to our projects. So it's actually very much to do with the technology transfer. Often, I mean, innovation doesn't stem from architecture necessarily. I mean, if you look in other directions, other industries, could be medicine industry or the car industry, there's a lot of focus on how you can push the limit of manufacturing, push the limits of material design. So very much of our focus is looking outside the boundaries of architecture, also looking outside the boundary of just working with architects. Today, when you work, I mean, 90% of the time you work with yourself. Next 10% you actually maybe talk to the people from your company, and they're all architects, at least in a more generic practice. So that's what we try to do. We actually try to include a lot of other professions in the work we do. So currently we're working with biologists and chemists, artists, engineers, etc. And it's that work that I'd like to give some examples on. This is one of our projects in Copenhagen. It's a law company. And the thing about this is that we like to work a lot with the geometry in the buildings, to work with this kind of a sculptural approach where, I mean, form is more than just more than just aesthetics. It's functions, it's performance. And in this particular project, if you see it from the south, it really shields off the sun. So we use the geometry to create this kind of natural sun shading, which prevents the building from overheating, which is the most significant problem you have in talking about energy performance in Denmark. But seen from the north, it's a very open building, and it completely opens up towards the water where it sits. So in that way, we like to talk about combining aesthetics, expressions with the functions and functionalities. In this case, the lawyer gets a very nice inner experience with a bay window, and at the same time we're getting a high energy performance of the building. And it also leaves a kind of a architectural statement that I find quite appealing. Doing this, it took some years actually to come up with this concept and find out how can we do this within the budget, and also how can we rationalize the geometry so we're only using 2 molds to build the facade. And in doing that, we were of course looking into which materials to choose, work with. Working with steel construction would be very heavy, it would be very complex. So we ended up deciding to actually try and do what windmill industry is doing. That is working with a structural sandwich composite. And I mean, this to me is where the project gets really exciting. Doing that is something that has been going on since Ray and Charles Eames did their chair designs since the windmill industry really took off decades ago. So it's actually materials that has been innovated and materialized in other industries. But it took a lot of time to get it through the building codes and all the testing and stressing, etc. But that's what I like to talk about. That's how can we look at design that's often invisible for the human eye. Giving some examples on that is like materials that excites me. This spring we had an exhibition called Material World, and I think it shows that how people today can engage with material. I mean, when I graduated as an architect, I was more thinking about materials as like in defined categories of stone, metal, glass, etc. And today material has really become an object for design. Good example is, for example, this bendy wood, which has this capability of being extremely flexible. So in the making of the wood, you can heat up the wood fibers and compress them so that you actually have wood that you can do nuts with. Other examples is not just in the material structure, but in the manufacturing way. This is a flooring system where, I mean, cutting up trees, obviously they're never straight as we see them when they're laid out on floors. So actually this movement of the wood is being scanned in a digitalized process, and in that way it can actually match the sides of the wood and optimize the use by 10%, and it also leaves again an interesting aesthetics. Other example, just 3 examples on wood here, is how you can take softwood and through a natural acid process with vinegar, you can make this wood perform the same way with qualities of hardwood. So, for example, this product is guaranteed 50 years of lifespan, even though you have it into soil. This is electrospinning. I really like this because you can't see it. It's so fine fibers that is being spun with an electromagnetic field, and just leaves very, very fine textile that you can put on other materials. And I think that's interesting. Often materials is something that you can touch and you can feel, but today materials is something you can apply on other surfaces to create other behaviors and other specifics. This is a non-woven. It's a fabric that kind of could match this t-shirt I'm wearing. And the way it's been manufactured, you see the human hair on the top left, it's being infiltrated with water jets in a way so 1 square meter of this material has 7 square kilometers of material surface. So it makes it extremely highly acoustical absorbent. You don't need heavy fabrics today in order to deal with acoustics. You can also deal with the microarchitecture of the material in terms to reach these performance levels. a good example on how material science is taking off is when we talk about silk and spider silk in nature, which is the strongest material. It's up to 50 times as strong as steel. Well, spider silk is not possible to mass produce due to the aggressive nature of spiders. So what scientists have done today is that they have isolated the protein of the silk and gene manipulated this into a mountain goat. So now you can actually start to milk spider silk of mountain goats. Other examples on how material really are being designed from bottom up is nanotechnology's carbon nanotubes. So this material is named after the diameter of the tube, which is 1 nanometer. This means that the way you build this material is really with the smallest building stones in nature, the atoms. And you can take the carbon atoms and create these tubular structures, and it has a strength of 100 times that of steel. Today, science allows us to grow this in half an inch length, but already now you can start to use this as reinforcement materials in composites and in concrete, just creating whole new possibilities in terms of material use, heights, dimensions, cantilevering, etc. So some examples on projects where we're working with these potentials is the Cube, a project that we won in the center of Berlin next to the parliament. It's completely covered in glass, and of course doing that daylight is a huge issue in such a massive building. To do that, we try to work with transparent insulation, and this is aerogel, also a material that was invented in 1932. This is the best insulating material in the world. And normally when we talk about insulation, it's very much about getting air to stand still. You could say like in mineral stone wool, you have like this filtered, threaded stone. And in those pockets, you have the air standing still, creating the insulation value. Well, with aerogel, this is something that happens inside the material in a molecular level. So this is why you can actually have 1 inch of aerogel insulating the same of that as a normal brick wall. Also another characteristic of this material is it's so light. It consists of 99.8% air, and it gives it such a light structure that the light travels through and creates this potentially translucent facade systems. Well, on the outside of the glass, we're working with an air purifying and self-cleaning effect. This happens when the building is exposed to UV light from the sun. A chemical process starts up that is creating self-cleaning behavior, which results in lower maintenance of the building. At the same time, it also starts to break down the industrial pollution from the surrounding area. And applying this on all surfaces, the building is actually self-cleaning, at least with a lower maintenance need, and at the same time giving something back to the city, purifying the air in the near context of that in the center of Berlin. Well, when we go inside, the client wants a very specific indoor climate of 21 degrees Celsius. Don't know what that is in Fahrenheit, but it is a very kind of pleasant temperature. Could be close to what we are experiencing here. Well, to do that, we want to make a material solution instead of just working with mechanical cooling. So in the ceiling systems where we have plastered solution, well, we embed in this plaster small pockets of polymer where you have phase-changing material inside. So this has the ability to suck up all the heat when the temperature rises above 21 degrees. What happens is inside this plastic pocket, you have a paraffin as in candles. And this material is designed to change its phase from solid to soft at 21 degrees. So when it does that, it absorbs a lot of heat. And this results, in our case, in our building, to a much lower need of cooling and also a huge energy reduction yearly. So I'm going to give 5 examples on design strategies that we work with in GXN. Green design. I think building industry often is is kind of being approached in a wrong way, where we talk about minimizing and reducing. I mean, you all know that building industry is responsible for half the world's energy consumption, and also is causing 40% of waste production. So I'd just like to stop up and think like, what is that word? What is waste? Because waste is kind of a problem we create ourselves. It doesn't exist in nature. So how can we maybe start to eliminate the concept of waste, start to think about buildings as ecosystems inspired by nature? This is an example of a building that tried to make positive outputs instead of just minimizing footprints or minimizing energy consumption. This is a high school in Stockholm where the client came to us and said, I want to have a building that's producing air, producing energy, making food, and consists of materials that can be recyclable. So he challenged us to try to work with living materials, with plants, with algae. And a good example on this is that the past 2 years we've been together with the biologists mapping out the biological context of the site and being harvesting wild plant seeds in order to actually mimic the local nature. So now we have the ability to produce more than 500 wild plant species that are suitable for the Nordic regions of Europe, in order to kind of tailor-make the solutions when we talk about green roofs, green walls. I mean, often you don't consider, so what is behind the word green? Which plants, which wildlife, which birds are you attracting? And what is the right thing to do with the focus of your local biotopes? Inside, this is a high school that is focusing on agriculture. So all the students have to learn about new industrial ways and urbanized ways of food making. We work with aeroponics and hydroponics in order to show how food can be controlled or produced in controlled conditions. This leaves no need for pesticides. It also accelerates the growth speed by 8%, for example, with strawberries. On the facade systems, we're working together with Arup on making a facade where we use algae as the solar shading. So how can algae, how can you take advantage of that as an organism that has the ability to, from the start of the day, go in an opaque window and then grow during the day to becoming all green and work as a solar shading. At the same time, beside having a real pleasant aesthetical effect, we're also generating a lot of energy from the thermal gains in the cavity from the water, and and also we can harvest the biomass from the algae. So this is our vision for the building that is allowing for air purifying food production, both for itself and its local community. Informed design, to us it's important in the very early phases of a design process to kind of inform the decisions that we are taking. We do that working a lot with the softwares that we're developing in order to interact in the first week, the first 2 weeks of a design life. I mean, a building's design life can be up to 3 years, but it's actually in the first 2-3 months that all the decisions, or at least 90% of the decisions, is taken, where you talk about building geometry and huge decisions that is really at the end where the most impact is done on the ecological and environmental performance of the building. So this is some high-rises we're working on in India, and doing these iterations as we are developing the project, we get learnings of how do the geometry actually create good daylight, at the same time also working with self-shading effect and minimizing energy consumption. Also, in other projects, in the later phases of the design life, we're also working with informed design. This is a project in Denmark. mixed use and a high-rise scheme, where you can see the balcony design is quite significant, and it's important for us to be able to ongoingly make adjustments to this, and that can be for inner qualities. It can also be for environmental or economical performances. So this allows us to actually live in the very late design phases, have this flexibility in the project. Behavior design. To us, behavior is strongly connected to architecture. We believe that buildings can make people talk more together and can make people learn in new ways. We believe a lot in interaction, and doing that is a focus that, of course, is a strong intended and implemented way of making our projects, but also when we're done with the projects, we go back to do post evaluations. For example, this is a bank in Denmark where you see the signature roof, and behind that roof you have this layout. Actually, the lower part is a public accessible cafe, kind of a square in the city. And up here you have the employees working, and of course we really wanted to have this kind of terraced layout of the floor slabs in order to have dialogue between people in the building, but also to give local identity to the people working in this area towards this area. We wanted to use the staircase to make pauses and make natural conversation possibilities. So this is how we work. Doing that, we also go back, evaluate it, and also learn from that, and take that as an iterative process to inform our coming projects. Another project where behavior is the main driver in the development of the project is this college in Ørestaden. This was a challenge because we were told to give answer to a whole new educational reform in Denmark. And that's a reform where you don't think traditionally in classes, you don't think traditional in different sectors within the school, but you really want to have a lot of synergy and a lot of interaction. So the first we did was to get rid of all corridors. We wanted to have a huge dynamic space where kids could learn from each other, inspire from each other, where math and physics could create synergy. So instead of doing a traditional school, we decided to treat the building as a cityscape. So you can see like a cityscape with plazas and small niches. So there's a lot of variety in the space. It's not just about having one big open space. It's about having the possibility to do different kinds of activities. Also, the staircase, you will find that in many of our projects, is an important way to make people connect. Actually, we have locked up all the elevators in the building, so everyone has to walk the staircase every day. And something happens when you do that, like you slow down and you start to talk, you start to know each other. So that and a lot of this visual transparency and the open school concept was a strong driver in this. You can see the way people are studying at school is also like the way they study at home. Technology design. This is a way where we try to work with new technologies, with potential clients. For example, this is a light pole company where we were at 2 years ago, but still using the latest knowledge within solar panels, solar cells, and LEDs and directly shaped prisms in a way so this street light was generating more energy than it was consuming, and in that way giving electricity back to the city. Another example is work we are doing with Permastelisa, the facade company, where we are trying to take the most well-known material in facades, aluminum, and substitute that with that of glass fiber. So doing that opens up for a whole new set of understandings in facade solutions. Well, glass fiber, it's also lightweight, but has very low thermal conductivity. You don't have the same issues with cold bridges. I mean, since it's glass fiber, glass is the main ingredient, so you can actually glue this together with the glass of the building. It has the same kind of heat capacities. That, combined with the aerogel I showed earlier, leaves us the possibilities to make facades that are potentially translucent. In that way, the aim is to do a facade that has half the thickness and double the performance. This is a project that's been going on for a few years, and I think this is a product that will be announced next year by Per Mr. Lisa. So experimental design. I mean, this is my favorite category, because we as an innovation unit have to innovate ourselves in order to inspire the rest of the company. So often we take on assignments that we don't have the answer to necessarily. A good example is a restaurant in Denmark called Noma, where this guy, young chef called René, he came to us because what he's doing, he's totally reinventing the Nordic cuisine by focusing on ingredients. So all his world of food is to understand and grow natural ingredients from Nordic regions. He's also doing collaboration with the universities, with old plant species that hasn't been grown in long times, in order to work with food in a way to create aesthetics, create experiences, create compositions. And I'm just saying this because many of these words are words that we use as architects. And we found this kind of mutual ground as we are working with materials and innovation in architecture, and he's doing it in gastronomy, to do a food laboratory for him. So obviously we had only to work with Nordic ingredients. So we're using spruce, we're using birch, and we're using oak. This is the house in which he has his restaurant, and it's an old brick building from 4 centuries ago. And this brick is also a source of inspiration. We're really working with components in the project, and the way we can rearrange them and create new forms and movements is very much connected to masonry. So first time I came and visited him, he had all these boxes filled with fantastic ingredients. So the whole project actually stemmed from, let's make these boxes the visual display of the food laboratory. So this is a zoom in on the project, where now in his food lab he has all these great ingredients shown, and it's built up in an all wooden structure. And the challenge was, in this case, not to touch anything. Since this is a listed historical building, we needed to do like a build-up using no screws, no nails. So everything is assembled by hand to be disassembled again. This is talking about the project as getting hands-on as architects. We developed software in order to do a design-build process. So this project consists quite precisely of 294 sheets of veneer, more than 5,000 individual parts, and just let it milled out for 11.5 kilometers. All of that we put together ourselves during the summer break, in which the restaurant is closed. Having this kind of eroded structural inside, where we are applying the boxes on the outside. Also, our office looked like a mess due to really doing the manufacturing in-house. Well, so this is a project where we have light rod behind in this eroded structure in order to allow light to shine through the boxes. And this is a project as it stands today. So to us, it was a challenge to work extremely simplistic in the final expression, but working with a high complexity in the process, working a lot with parametric modeling and design-built experiences. This is some snapshots from the plant trolleys, and the whole project was actually a real good chance to actually do details of everything. So it was everything from the coat hanger to the cutlery boxes to the lamps, and it just creates a space for them where they can, as they are experimenting, still go in depth with the food they're making. So the last project of today's talk is a pavilion, a sculpture. We were asked if we wanted to participate in an exhibition. It was a Danish museum called Louisiana who asked us if we wanted to showcase what you can do with intelligent and sustainable materials. We took up that challenge, saying we want to show two things. We want to show how sustainable materials and materials in general can be designed in order to be reused endlessly, either in a biological circuit or or in an industrial circuit. In that way, we also wanted to express how materials can actively have a dialogue with their surroundings. Today, many buildings are very static. We just try to keep either heat or cold outside or inside. In this project, we wanted to show that you can actually harvest energy from your surroundings and be a dialogue, a more dynamic approach. This is Kim, the founder of 3XN. Him and I, we had this idea about making a sculpture that talked about eternity in the kind of geometry of a Möbius strip. So we spent a few weeks in the lunch breaks to come up with this shape. And we used that as a kind of a test bed to showcase how you can integrate a lot of different materials. For example, we had the phase changing in the mix. It was a biocomposite structure. So doing that made the sculpture nice and cool during the days with the hot sun, and at the nighttime it will release this heat in order to create a kind of a pleasant surface to sit upon. Well, also we worked with surface treatments that were self-cleaning and also air purifying. In the kind of lower parts of the sculpture, we wanted the kids to play on it and run on it, and doing that, their energy should be captured by the sculpture. So we had these small piezoelectric ceramics and the material that, when applied force, converts this force into electricity. Oh, yeah. So having that actually generated energy from the movement that was displayed in an LED integrated ceiling. Well, the biggest challenge was actually to find the ingredients or the materials to build with, because we wanted to do a biocomposite. Composite, as you know, is when you take more than one material, two materials, and put them together, and they have combined greater qualities than they have individually. And we wanted to take materials like flax fiber, like cornstarch and oil, soybean oil, in order to create a strong and stiff biocomposite. So we also engaged with some talented engineers and manufacturers from the UK, and getting all their workers to work with cork, with flax, and with soybean and cornstarch was kind of a challenge. And well, we laid it out and had different strategies of how to mold and demold, and suddenly they just called me one day and said, like, you need to come here. And I just literally got on a plane, went to the factory, and it was 2 weeks before the opening, and it looked horrible. I mean, it was really just not in the way we were hoping to. Well, I convinced them to really step up and work round the clock. And after getting to know the curing times, getting to know the kind of fiber characteristics, I actually managed to work with this material. And this is a photo before the sculpture was shipped to Denmark. Well, what happened was that this project was only over 3 months duration, And in that duration, we had 20 different companies applying a lot of materials and working together. And making this biocomposite was actually a material we invented without knowing it. So putting this cork and flax and soybeans and cornstarch together made us actually get an award for an environmental approach in the composite industry. And that was a real benefit, actually giving something back to an industry that we normally steal a lot from. This is a sculpture today, and it still stands, and it's a kid's magnet, and that's also my last slide. Thank you.